Distinguished guests, dear judges, ladies and gentlemen, good afternoon.
Good afternoon.
My name is Xu Wen.
I am Zhu Yuan.
We are from Dongtai City, Jiangsu province of China, a city with a beautiful scenery and a rich natural heritage. We would be very honored to invite you to visit our city in the near future.
We are a quality control circle from State Grid Corporation of China. As the largest public utility in the world, State Grid Corporation of China takes investment, construction, and operation as core business. For the past 20 years, we are the only company in the world who has never had a large-scale blackout. Our team consists of 9 members, and we are responsible for the maintenance of distribution lines and equipment of the grid. Our quality control circle is nicknamed the Golden Starfish.
How we got this name?
Because the Yellow Sea has always been known as the Golden Coast, and we are the best service, the star of the Golden Coast.
Our presentation is about the research and development of an assembly platform for lead-down equipment of distribution transformers on high voltage. Why we choose this project?
At the beginning of 2017, at the working conference of our company, we were directed that our department's primary concern is to provide customers with sustainable products and services, as well as improving power supply reliability and business environment. So it was made clear that the power outage time of distribution transformer renovation project does not exceed 480 minutes.
We collected statistics on the power outage time of the 2016 distribution transformer renovation project. There were 263 projects with an average time of 520 minutes and a maximum of 550 minutes, which is quite higher than the company's target of 428 minutes. Therefore, shortening the power outage time was an urgent problem we needed to solve. Why was the time exceeding the requirement by so much? We analyzed the current engineering methods to find out. At the time, the engineering methods were mainly divided into 5 steps: pole setting, bracket erecting, transformer installation, the lead-down equipment manufacturing and installation, and high voltage connection. Among them, 4 out of 5 are constructed via grant. Once installed and assembled, there is basically no space for time-saving measures. But the lead-down equipment manufacturing and installation step takes 200 minutes, accounting for 38.5% of the total time.
The lead-down equipment manufacturing and installation mainly includes 7 working procedures, primarily cable cutting, cable insulated stripping, copper and aluminum joints installation at both end cable, cable bending and insulator binding, connect the insulator and the cables, installation of grounding rings, and final installations. All of them were carried out manually on the pole through on-site operation. The old manual working procedures was inefficient, time-consuming, and didn't meet the company's requirement. The success of our project changed this. Here are some of our cumulative improvements. In the fourth quarter of 2017, after implementation of our project in our city, the decrease of the power outage time has been about 660 hours. If this is extended to the whole province, it will save at least 27,000 hours.
Before the success of our project, many technical problems had to be solved. Let's show you how we made it possible. We held a brainstorming conference to seek breakthroughs in the improvement of the lead-down equipment manufacturing and installation step. By searching CNKI and Wanfang data, 2 papers had great insights that help us find a solution. Reference 1 is auxiliary tools for installation of communication cables. And the reference point is to change the wire connection to the equipment that is manufactured and installed step by step on the pole to installing on the platform, and then connect separately on the pole.
The reference 2 is bending method for communication cables on the support. And the reference point is to transform the manual bending work originally performed on the site to the indoor bending site.
We proposed the following plan. As the purpose of the project is to reduce the power outage time, we proposed reducing the lead-down equipment manufacturing and installation step from the original 200 minutes to 45 minutes. This became the target of the project. Could the goal be achieved? We had the following resources at our disposal.
In addition, through reference and analysis, the base time of cable bending could be effectively decreased with the use of mechanical force for automatic bending, which saves time and effort. The lead-down equipment manufacturing and installation time could be reduced to less than 45 minutes as our expectation. So therefore, the target could be achieved.
An indoor integrated assembly platform was used to shorten the original 7 steps to 2 steps.
This method was used for the first time in the construction of transformer renovation project in the state grid system. We select the first level and the second level programs for the 6 aspects of platform function and overall capabilities. Let me show them to you one by one. First, we chose the interception method. There were 3 comparable programs. By comparing the cutting error and the cost of the 3 programs, we found that the hydraulic clamp cutting method has higher benefits than alternatives, so we chose this project. Next, we chose the support method. By comparing the advantages and disadvantages of the 2 programs, we found that the adjustable support method has higher benefits, so we select this.
The third step was to select the bending and crimping method. When automatic hydraulic bending and crimping is adopted, the pressure value was never less than 3 newtons per square millimeter. The fourth step was to select the strip-in method. When automatic strip-in is adopted, it takes less time. The fifth step was to select the electric circuit configuration. When the parallel circuit is adopted, it meets the requirement that the synchronous response rate is never less than 95%.
The sixth step is to select the platform layout. By comparing the 2 programs in terms of suitability and factory production, we found that the structured product configuration has benefits of high efficiency, low cost, and small floor space, etc. So we select this for overall installation. At this point, we have selected all the first level programs, and we also selected the second level programs for the adjustable support method. In the test, we found that when the guide rail are adjustable, the benefits are higher. So we select this for the second level program. So far, the best solution is shown in the figure.
Next, we developed a detailed plan for 5W1H and implemented it according to the plan.
First, we made a hydraulic clamp cable cutter. After testing the hydraulic clamp cable cutter on site, we found that the cutting time did not exceed 10 seconds, achieving the goal. Next, we made a pneumatically adjustable guide rail through independent research and development. In the test, we found that the displacement during the production was less than 0.1 millimeter, and the movement of the insulator within 200 to 450 millimeters, achieving the goal.
In the third step, we developed an automatic hydraulic bending and crimping device, which met the requirement that the pressure value was never less than 3 newtons per square millimeter. In the fourth step, we developed an automatic strip-in device, which met the requirement that the cable strip-in time was less than 5 seconds, and the cost was also less than $215.
Next, the team leader designed a parallel control circuit and select the component parts. In the test, we found that the synchronous response rate met the target requirement. Subsequently, the team made an overall arrangement according to the design of each part and improved the fixed plan according to the material problems that appeared. We also made the PDPC complete the overall installation utilizing the base solution path, and the intermediate non-component production time was less than 60 seconds, achieving the goal. Finally, we complete the installation of the platform and test the results. These show that the component could be effectively connected. 30 different points on the platform were selected, and the plan strengths were tested. And the result met the target requirement. Now, let's see how the platform works through the video.
After the project was completed, we tested the usage time of the new platform. We found that the manufacturing and installation step decreased from the original 200 minutes to 40.5 minutes, achieving the goal of within 45 minutes. And the power outage time also met the company's requirement.
In addition, our project also saved a large amount of engineering costs. If there were 15,000 new projects in Jiangsu company in 2017, it would save at least $900,000 in 1 year.
The equipment failure rate and number of repairs were greatly reduced, and the standardized management of the distribution network was realized. The equipment failure rate and number of repairs reduced, and the standardized management of the distribution network is realized.
After 3 months of practice, we successfully shortened the power outage time of transformer renovation project, and the customer satisfaction rate raised from 98.5 to 99.2%, and the power supply reliability raised from 99.85 to 99.95%. And our company has reached the first-class level in the state grade system.
In order to standardize the innovation outcomes, we prepared instructions as well as technical specifications. At the same time, we carry out relevant training to take the project from theory to practice.
In December of 2017, the production platform received the acceptance of the expert group from the state grid system and was fully promoted throughout the province.
The success of this project not only solved our online production, but also provided a good reference for other line equipment. Furtherly, let's review the pleasant effect of our QC Circle and the improvement of the overall level.
公司通过开展 QC 活动，员工的凝聚力、创新能力得到不断提高，部门协作能力不断增强，客户满意度也得到全面提升。QC 小组活动将在企业发展中发挥越来越重要的作用。
通过本次活动的开展，不但改进了批货施工质量，降低了材料消耗，提高了经济效益，我们办元件的凝聚力、创新力得到了全面的提升。
Next, in view of low production efficiency of the grounded flat iron, we decided to develop an integrated production platform for the grounded flat iron in the future. Innovation inspires infinite growth.
Innovation drives the development of the power grid,
And we will never stop innovating.
Let's create a brighter future through TQM and QC Circle activities. This concludes our presentation. Our sincere thanks to Japanese Union of Scientists and Engineers for giving us this opportunity, and thank you for being a lovely audience.
Any questions from audience?
Okay, thank you for your presentation. And as my job is mainly about electricity, and wonder what is your benefit of your project?
Thank you for your question. The production environment, quality, efficiency, and safety were greatly improved. And the standardized management of our project was realized. Besides, the standardized management of our project is improved, and the number of repairs were reduced too.
Okay, thank you.
Thank you.
Thank you.
Any other question? Please come.